All right, so welcome to our lesson, which is the first lesson in math. Okay, so we are going to be looking at the introduction to set theory. Okay, so if we explain anything that you do not understand, please feel free to ask. Okay, we want to learn, we want to share the knowledge that we know with you guys. Okay, so if you don't understand, just unmute your mic and then you can ask the question. Then I'll be able to explain so that we all know. Okay, so in math, this is going to be your first topic. You're going to be looking at sets. And sets are various concepts that you should know. Okay, you should know what a set is. You should know the types of sets that are there. Okay, you should know the common operations that we use. We should know how to represent sets. Okay, so that is roster form. And then we also have the set builder notation. Okay, you should also know the interval notation, the power sets, which is also a type of set. Okay, so you should know those concepts. So in today's class, we are going to be focusing on these few objectives that I've listed here. Okay, so I'm saying in this lesson, we are going to define what a set is. Okay, and then we're going to talk about types of sets, but on the types, we're going to talk about specifically, okay, two types of sets. So one of them is called the finite sets. Then the other one is called the infinite sets. Okay. And then from there, we're going to talk about the common operations that we use under set theory. So I know you know these. So those intersections, union, okay, we have the complement, all those operations. That's what we are going to talk about. All right, so to start with, we are going to define a set. Okay, so what is a set? Okay, so earlier I sent videos for you to watch. Okay, so those who have watched, they can agree with me that a set is actually a collection. Okay, a set is just a collection of well-defined objects. Okay, well-defined objects. So this is what a set is. Okay, so if the objects are not well defined, then we cannot refer to that set as, we cannot refer to that grouping as a set, okay? Because the set, then the objects have to be well defined. You shouldn't have any doubt that, okay, when I get this set, I'm going to find such and such things, okay? So for example, when we say a set of markers, okay, a set of markers, and then another person says a set of blue markers. Okay, so these two statements that I've given, one of them is a set, the other one is not. Okay, so when you say a set of markers here, okay, this is not well defined because we don't know uh, what color or what types of those markers we are going to have. Okay, but when you say a set of blue markers, this is well defined. It's so specific. Okay, you know that uh, when I open this box, okay, I'm going to find blue markers. There's no doubt about that. But when you just say markers, you don't know what you're going to find inside, right? Maybe you can find black markers, white marker. They are white markers. Maybe you can find green or red. Okay, we do not know. We are not certain. We just know that okay, there are markers there, but we don't know the color of those markers. Okay, but when we say the set of blue markers, or we can say a box of blue markers, then we are certain that in that box we are going to find blue markers. We have no doubt what we're going to find when we open that box. Okay, so that is what we call as a set, a collection of well-defined objects. Okay, so now these sets, okay, are classified uh, in a number of ways. Okay, so meaning that we have different types of sets. Okay, we have different types of sets. But for today, I want us to focus on the finite sets. Okay, this which is what we are going to discuss today. And then there's also what we call as the infinite sets. So what are finite sets? Okay, anyone who can try. What comes to your mind when you hear finite sets? What comes to your mind? Okay, so these are sets, okay, that contain countable elements. Countable elements. Okay, these are sets that contain countable elements. So meaning when you are given that set, if it is called a finite set, then you'll be able to count how many elements or how many members you have inside that set. That's what we mean by what? Finite sets. Okay, and then we also have uh, infinites. Infinite sets. Okay, so infinite sets, these are sets that have uncountable elements. Okay, you can't count how many elements or members are in that set. Okay, you will just have where they start from and where they end from, but you won't have uh, an exact number of how many elements are in that set. Okay, so to represent countable sets, we're going to use what we are using at grade 12. We're going to be using these two curly brackets if you remember them like that. Okay, so in grade 12, we said if you're given set A, it's going to be something like this. Maybe set A contains 1, 2, 3, 4. Okay, so these brackets here, which are called carry, okay, brackets, are what we are going to be using to represent finite sets, meaning countable sets. Okay, so you can see here, I can actually count how many elements I have in this set. I have 1, 2, 3, 4. That's all. Okay, and then for the infinite sets, we're going to be using two types of brackets. Okay, we have what we call as the curved brackets, like these ones, and then we also have what we call as the square brackets, like these ones. Okay, so these curved brackets, they simply mean the endpoints of this set. Let's say I have A comma B. The endpoints of this set are not included in that set. Okay, so we can say this is set A. So it means A and B will not be in the set A, but anything that comes just after A is here, and anything that is just before B is also there. Okay, and then I can also write square brackets like that, meaning the endpoints there, A comma B, will actually be part of this set. Okay, so this set will start at A exactly, and then everything in between A and B, and then it will end at what? B. So for the infinite sets, okay, we are going to be using these two types of brackets, and that's where we are going to talk about set interval notation. Okay, interval notation with these brackets here. So we explain more in another lesson. So for today, I want us to talk about this one because it's just a continuation from your secondary school. Okay, so finite sets, we said they're represented by these types of brackets, and they indicate sets that are what? Countable. That's what we said. Okay, so these ones are going to help us list out the members that are in a certain set. Okay, so in short, they're going to help us put the set in what we call as roster form. So roster form simply means listing all the elements that are in that set. Okay, all right, so those are the types of sets. And then now we can talk about the common operations that we use. Okay, the common operations that we use. So the first one is what you know. It's just the intersection. Okay. So intersection simply means common elements. Okay. Common elements between sets. Okay. Common elements between sets. Okay. Simply means if I have set A and set B, okay, the elements that are going to be in both, then they're going to be in the intersection. And then we have union, okay, which simply means that you are combining all elements. Okay, you're combining all elements in the given set. In the given sets. Okay, so if you have set A, set B, you get all the elements in set A as well as all the elements in set B. You combine them, okay, you're going to have a union of those two sets. And then what you should note under union is that if you have the same element appearing in two sets, you only write it once in the union. Okay, so if, for example, I had my set A being 1, 2, 3, and then I have my set B being equal to maybe 2, 3, 4. Okay, so if I'm finding A union B, what I'll write here is, okay, all the elements that are in here and there. But if there is anyone that is repeating, I'm only going to write him once. Okay, so we have a 2, we have a 2 here, we have a 3, we have a 3 there. Okay, so the 2 and the 3 are repeating. So I'm only going to write them once in this union. So I'm going to say 1, 2, 3, and then 4. So this here will be the union of these two sets. Okay. And then the other operation that we have is the one that indicates the universal set. Okay. So universal set is just simply all elements under consideration. Okay, all elements under consideration. So this is the universal set. Okay, what other operation? Okay, the other operation is what we call as the complement. Okay, so I can say A complement. Some people write it as A prime like that. So this line here, it's called a prime. So this is read as A prime. Okay, so simply meaning A complement. So A complement simply means we want elements that are not in set A. Okay, elements not in set A or any set that you've been given. So if you're given B complement, then you are looking for elements that are not in set B. Okay, D complement, then you're looking for elements that will not be in set D. So that's what it means to be a complement. Okay, and then the other common operation that you're going to encounter as you go in this course is what we call as the set difference. A very nice concept. Okay, the set difference. So this set difference is written as A minus B. This is the set difference. Okay, so the set difference A minus B, what it means is, okay, A minus B means A intersection B complement. Okay, but you see mathematicians want to be clever in anything, right? So they said, it will take a lot of time to write the intersection, and then I write again the complement. So what do? I just write A minus B. Okay, so they made it short like that. So whenever you see A minus B, just know it's the same as A intersection B complement. Okay, so it's the complement of the other set. So meaning that if I have C minus D, this here is the same as what? C intersection D complement. If I have B minus A, this is the same as B intersection A complement. Okay, so mathematicians are actually very nice people, right? Okay, they will save time. So that's what it means there. So that's the set difference. So we're going to be using this a lot when you start looking at questions. Okay, so know this, and then it's going to help us. All right. So do we have any questions so far on what I've explained? Any questions on what I've explained?
I have a question.
Yes, please ask.
On the A intersection B complement, on the set differences, are
Yes.
we finding the complement of B only, or it's A intersection B in brackets, then complement?
No, we are finding the complement of B only.
Oh, okay. Okay.
Yes. All right. Okay, so as we now look at questions, okay, because I'll go straight to the exam questions that you guys should be practicing, okay? So we'll be required to use whatever I've talked about here. We'll also be required to maybe expand, sometimes factorize, okay? But this is a very simple lesson. So if you get confused on anything, uh, please ask, okay? All right, so let's look at some exam questions. Okay, so this is the first question, a grade 12 type of question. Okay, so that we build on what we already know. So here they're saying, given that the universal set is a set that contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until 15. Okay, and then A is a set of set A is a set of prime numbers that are in U. Okay, so this U here represents the universal set. And then set B is actually the set that contains factors of 60 in the universal set. And then C is a set that contains odd numbers in the universal set. Okay, so here it means you also have to know the meaning of prime numbers, factors of a certain number, and odd numbers. Okay, so what are prime numbers? So I just write Pn. Okay, so prime numbers are numbers. Okay, prime numbers are numbers that are only divisible by themselves and one. So meaning prime numbers are numbers that only have two factors. Okay, maybe someone might not know, what do we mean by this factor here? Okay, what do we mean by factor? So by factor, we mean that a number that can go into a certain number, okay, without leaving a remainder. That's a factor. So if I say 10, okay, factors of 10 include 2 and 5 and 10 and 1. Why? Because I can divide 10 by 2, I'll get 5. So it goes there without leaving any remainder. Okay, or I can say 10 over 5, this will just give me 2. There's no remainder. 10 over 10, this will just give me 1. There's no remainder. 10 over 1, this is just 10. There's no remainder. But if I did 10 divided by 3, okay, this here will be 3 point something something. So there will be a remainder there. So we are saying 3 is not a factor of 10 because it can't go into 10 without leaving a remainder. Okay, so that's what a factor is. So a factor is just a number that can go into a certain number without leaving any remainder. Okay, so these prime numbers have a characteristic that they only have what? Only have, I'm supposed to write 2 here, 2 factors. Okay, itself and 1. So meaning there's no other number that can go into that number. Okay, minus leaving a remainder apart from itself and 1. So for example, the first one is the number 2. 2 is a prime number because 2, only 2 and 1 can go into 2 without leaving a remainder. Okay, and then the other one is 3. Okay, 5 is a prime number, 7 is a prime number, 9. Okay, is 9 a prime number? Anyone can try. Is 9 a prime number?
No, it's not,
Okay, why do you say it's not a prime number?
because it can be divided by 3 and 1 and 9. So it has 3 factors.
Exactly. Okay, so it has more than 2 factors, so we can't consider it as a what? A prime number. So we remove it there. Okay, so the next one from here, it will be 11, 13, 17, 19. Those are prime numbers. Okay, and then what are factors? Factors I've already explained here. Okay, so a factor is just a number that would divide into a certain number without leaving any remainder. Okay, so that's what a factor is. And then there I can also see odd numbers here. Okay, so what are odd numbers? Okay, so odd numbers, these are numbers, okay, that cannot be divided by 2, cannot be divided by 2 minus leaving a remainder. Okay, without a remainder. Okay, so meaning when I get this number and I divide it by 2, I should get a remainder. Then that number is going to be an odd number. Okay, so we are going to consider uh, what here? Okay, so I have a question. Since we are saying odd numbers are numbers that cannot be divided by 2 without leaving a remainder. Okay, so is 1 an odd number? Can we classify 1 as an odd number? Hello? Is 1 an odd number?
Yes, it's an odd number.
Okay, why do you say so?
Because when you divide 1 by 2, you get 0 and a remainder, I think.
Yes. Okay. So the odd numbers will start at 1, and then you go to 3, 5, 7, 9, 11, 13, 15. So those numbers that you cannot divide minus getting a remainder of 1. Okay, so those are odd numbers. And then even numbers, even if they are not here, we can talk about them. Those are just numbers that you can divide by 2. You can divide them by 2 and you have a 0 as a remainder. Okay, so now that we've known this, we can actually list set A, set B, set C, and then find whatever they're asking us to find. So let's start with set A. Okay, so set A, they said prime numbers in this set here, which is U. So let's pick prime numbers from this set. Okay, so the first one there is 2, 3, 5, 7, 9, no. The next one is 11, 13, and then that's all. Okay, because 15 and 14 are not prime numbers. Okay, so this is the set of prime numbers. So this makes up set A. Set B, they've said the factors of scarcity that are in this set here. So meaning numbers that are here that can go into scarcity without leaving a remainder. Okay, so 1 can go there, 2 can go there, 3 can go there. Okay, can 4 go into scarcity? Okay.
Yes.
Okay, yeah, it goes there. So 4 goes there. 5 also goes there. 6, okay. Can 7 go into schist? No, it can't. Okay, so 7 cannot, 8 cannot, 9 cannot, 10 can. Okay, so I'll write my next one as 10. 11, I doubt it doesn't. Okay, 12, it does. So 12, I'll write it in this set. And then what about 13? Does not. 14 does not. 15, it does. So these ones here, okay, is the set of factors of scarcity that are in this universal set. And then C, we are told that it's what now? C, we are told odd numbers, okay? So odd numbers that are in that set, this one here. So these are numbers that cannot be, that always have a remainder of 1, I mean. Okay, so we'll start at 1, 3, 5, 7, 9, 11. Uh, what else do we have? We have 13 and then 15. Okay, so these are odd numbers. When you divide them by, you divide by 2, you're going to remain with a remainder 1. Okay, so now we have listed all our, okay, we have listed all our sets. Okay, so now we can answer the questions here. So the first one, they're saying A, find A intersection B intersection C. Here, we're simply looking for common elements between the set A, B, and C. Okay, so which elements can we see here, there, and there? Okay, so I can see 3. So 3, I can see it here. I can also see it there. I can also see it there. So it means I'll put 3 here as my starting number. I can see 5, 5, and again 5. So I'll put it there. Okay, what about 7 here? I can't see it there, but there it's there, so I can't include it. 11, I can't include it. What about 13? I can't include it. Okay, so I'm just finding this, yeah, as my intersection. Okay. Am I correct? If you're seeing any number that is common there, you can mention it. But I think we are good. It's just 3 and 5. Okay, 3 and 5. All right. So that would be the answer for A. And then B. Okay, we have A complement union B complement. Okay, so this one we have a number of ways in which we can solve it. Okay, so it all depends on which one you think it's simple. Okay, so later on we're going to talk about some set laws. Okay, they are called De Morgan's laws. Okay, so De Morgan's laws simply state that if I have A intersection B complement, this here is the same as A complement union B complement. Okay, so this question we can actually solve it by De Morgan's laws, or if you don't want or you don't know the De Morgan's laws, you can simply find the A complement and then you unionize it with the C complement. Okay. Okay, so let's do that. Okay, let's do the simple one before we put in these laws. So A complement is just all the members that are not in A. Okay, so I'm going to list A complement here. So I'll be looking at this and comparing it to this. So 1, 2, 3, 4, 5. 5 is there. 6 is not. 7 is there. 8, 9, 10, 11 is there. So I jump it here. 12, 13, it's there. So I jump it. So I have 14 and then 15. So this is my A complement here. Okay, based on my A that I have. This is my A complement. So what you should note that if you add or you combine the complement with the set, it should give you back the universal set. Okay, so if I combine this with this, I'm going to get back my universal set. Okay, and then what is my B complement? So we're going to say union here, and then let's list the B complement here. So the B complement, we are comparing this set here to the universal. So I start 1, I can see it 1. So I jump it 2, 3, 4, 5, 6, and then 7, I don't see it. 8, 9, 10, I see it. So I jump it here. I go to 11, 12, I see it. So I jump it, I go to 13, and then I have 14, and then that's all, because 15 is there. Okay, so this is my B complement. In short, members that are not in set B. So now let's combine these guys, okay, to make one set, which will be our A complement union B complement. Okay, so we're just combining this with this, minding, okay, that if there's any number repeating, we should only write it once. So I start with the smallest, 1, 4, 6, again, I get to 7. 8 is there in both. So I only write 1, 8. 9 is there both. I only write 1, 9. Then I have 10, 11, 12. I have 13. 14 is there both. So I write it once. And then I have 15. Okay. So this, what I've listed here, okay, that is going to be my um, A complement union B complement, like that. Okay. Right, so if there are no any questions there, please ask, okay? But we can get that same answer by just using what we call as the De Morgan's laws, these ones here. So I'm going to say this part here, okay? By definition, it's the same as A intersection B complement. So I write A intersection B, and then I write complement. So meaning that I can easily just find my A intersection B, and then I find its complement. Okay, so what is my A intersection B? Based on these sets that I have. Okay, my A intersection B is that I can see 2. Okay, I can see 3. The things that are common between this one and this one. What else? 7 is not. 11 is not. And then, okay, so 2, 3, 5. Okay, 5 is common. So I can see 5 here and 5 there. So I'm going to write it here, 5. And then what else is common? Okay, I think that's all. Okay, so from here now, we can get the complement of this, which will be the same as this. Okay, so in the universal set, I had 1 to 15. So I'm only removing 2, 3, 5. So it means I have 1, okay, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so you see that we can actually solve it using the De Morgan's laws, or we can solve it here the normal way, but we are going to find the same answer. Okay, but when you use this, it's actually simpler because just get the intersection and then you find its complement and then you are done. Okay, so any questions there? Okay, so let's look at the last one there. Oh, I've erased the sets. Okay, so the last one is just the union, which is very simple, right? Okay, it's just the union, which is very simple. Okay, so C, we are told to find A intersection B and then union C. Okay, so we can actually group this into two parts. First of all, we find the A intersection B, and then we find the A intersection B union C. So I'm going to write this. Okay, so first of all, I'm going to write this set here. Okay, so what is common between A and B? We already found that it was 2, 3, and 5. This was what was common between A and B. So this is the A intersection B. And then I'm unionizing this one with my set C. 11, 13, and then 15 like that. Okay, so we can unionize this. We only get what? We get 1, 2, 3, 5, 7, 9, 11, 13, 15. And that is our answer there. Okay, so any questions there on what we've done here so far? Any questions? Okay, so if there are no questions, I think we can end here. Okay, this was just an introduction. I hope you've learned something. Okay, if you had forgotten, I hope you've learned something. Okay, so next time we'll come and continue from there. Okay, so next time we'll look at the infinite sets. So meaning we'll be looking at intervals. Okay, we'll be looking at intervals. Okay, otherwise for today it's just a start. This is enough. Okay. So I was getting these questions actually from tutorial sheet 1 of the January intake. Okay. Of the January intake. So on our website and our app, we have videos explaining all these questions. So very soon you're going to be given a tutorial sheet. Okay. So the number one thing in math is to solve each and every question that you can see in the tutorial sheet. And then when a quiz, a test, even the exam come, okay, it will be very simple for you because the concept that they'll be getting, they'll be from the same tutorial sheet. Okay, so for those who are ambitious, um, courageous enough, okay, they want to start learning these things. Okay, we have um, videos on our website explaining all these questions. So this is just tutorial sheet 1. You can see all these questions there. Okay, all these questions up to question 19, question 1 to 19. Okay, so you can access them on our website and our app. So the good thing about our app for those who are using Android phones is that you can download the videos and watch them offline. Okay,